Welcome to part 2 of our Structural Attributes series, reviewing the structural attributes available in Doug Insight. Check out our Doug Learning section and YouTube channel for part 1. Structural attributes are used to measure either similarity or dissimilarity between neighbouring traces. They use differing methods to achieve this and are data dependent. They can give great results if you understand what the input parameters mean. This video will cover semblance, directional correlation, and edges. These attributes are used to investigate datasets for structural changes, such as faults and stratigraphic features, such as channels. Here I have an insight session showing some clear faulting in the section view. The upper left map view shows a slice through the same volume at 900 milliseconds, marked by the blue line in section view. Faulting is seen in the slice view, but not as clearly as in the section. The upper right map shows the pink horizon visible in the section. The faulting is clearer in this map view, identified by a rapid change in colour. I can create a semblance volume in the Process tab. Create a new process, select Semblance from the list, and then provide a name, or accept the default name for the new volume. Add the input volume. The input parameters are similar to our previous attributes in part 1. Anything greater than the maximum dip of reflection events that Insight should allow will not be recognised as a similar event. Run a quick calculation based on the general dip of our horizon by using the measuring tool and calculating the gradient of a line. In this case, the change in vertical, 70 milliseconds, divided by the change in horizontal, 1000 metres, gives a dip of 0.07. Let's round this value up to a parameter setting of 0.1. The faults of interest have approximately 140 millisecond throw, giving a half window of 70 milliseconds. So what is Insight doing? Semblance is similar to the incoherence and correlation similarity attributes seen in part 1. However, it uses a semblance calculation instead of correlation. Semblance is affected by variations in amplitude and waveform, so can be useful for detecting subtle depositional features or for getting clearer images from noisy data. Semblance is calculated by taking the ratio of the energy of a trace to the energy of neighbouring traces within an analysis window. At each sample, a semblance calculation is performed over the analysis window to determine the similarity of an individual trace to surrounding traces. For a direct comparison to incoherence, the reverse output option is ticked on by default. When reversed, high similarity values will have a value closer to 0, while low similarity values will be closer to 1. I can create a directional correlation volume in the Process tab. Create a new process, select Directional Correlation from the list, and then provide a name, or accept the default name for the new volume. Add the input volume. Directional correlation uses correlation also, but adds an azimuthal component to the mix. The maximum dip and half window settings are the same as the semblance and correlation processes. Remember, the smaller the defined window, the longer it will take to calculate the attribute. The map view horizon shows a clear fault strike direction that I can measure using the measuring tools. In this example, I'll enter the azimuth as 55 degrees. Any discontinuities parallel to the specified azimuth will be enhanced while features perpendicular will be suppressed. 55 degrees should capture my faults nicely. The final parameter, inline or crossline half window, defines the horizontal calculation window. Best results are seen when the input is a square. I'm going to double my half window to check for improvements. In this dataset, some faults in the map view are enhanced at the expense of others for this larger window. The final attribute is edges. This process requires a generated dip field. The dip field algorithm is applied separately in the inline and crossline directions. Insight calculates dips by dividing the change in the vertical dimension between adjacent samples by the horizontal distance. Notice the similar input parameters to the previously calculated structural attributes. Using a group of dip field with the original stack, you can check that the dip field is captured correctly. Create the Edges volume in the Process tab. Create a new process. Select Edges from the list and then provide a name or accept the default name for the new volume. Add the dip field. Add the input volume. The Edges attribute highlights changes in movement and direction of vectors in a dip volume using a Sobel operator. A Sobel operator is used as an edge detecting algorithm in image processing. Different attributes will show different aspects of your input data. Why not give them all a whirl and see what pops out? Grouping these attributes and flattening them to preserve the depositional environment can help delineate structures in more detail. Watch the rest of the video series to learn more about structural attributes. If you have questions or would like to discover more, then visit our website at www.doug.com. And remember, have fun with Insight.